This video is to address questions about scaling figures of different heights. Week 4 of the perspective course, we look at doing figures, and the process shown is pretty straightforward, but it only deals with one height. So that definitely leads to a situation where people are going to want to rate different heights, do different things. How do we show an understanding of a pretty simple idea compared to what we've been doing of scaling figures with something like a little more complex situation of different heights, different ages, different all kinds of factors. There's a lot of room there to kind of build off of it. So, simple process, we have our horizon line to start with. The box here is representing a figure. In this case, the figure, we're going to use an arbitrary number of 6 feet, but that becomes our baseline. We take the box, we divide it using measurements from week 2. We now have a 3-foot mark. We also have a 4.5 foot box. Overall height, so 6 times 12, you get your 72. If we cut this in half again, we take an 18-inch section, we break it down to 9 inches, so we've got our 72. We go to 63 inches, so that would be 5'3". 5'3" to 6 foot is a good range for most adults. So you're gonna, we could go figure out statistically where that falls, but that's most people are probably going to fall in that range. So that's a fair range to work with. Now, obviously there are people taller than 6 feet. During the discussion I've heard, basketball player came up. Obviously they're going to be very tall. So how do you deal with something like that if you're using a 6-foot base? We can use the horizontal transfer. So people that are in the same position in depth to us, so they're closest to us, not necessarily at an angle, but just going back kind of linear. Just transfer that over. So what do we do with this? We know that this is 6 feet. We can use the process that was explained for fences. And basically we have our center line now. We're just using the centering X's to create that middle line for us, making sure it stays in perspective. And then using, let me turn off arrows, I believe I have them on. Using that diagonal, we go from one corner through the center. Now we've extended that. So we now have another, and because there's no convergence going on here, nothing else going on, this measurement, we could just measure it straight if we chose to, but we also know there's another 1.5 feet. So now we're at 7.5 feet tall. That's going to accommodate pretty much everything you need to until you go into more fiction kind of base scenarios. But that's a very simple way of adding that height. You could do the same thing here if you wanted to just add it in segments of once you had your divisions, using your center line and just adding that little bit more. So in this case, we talked about 9 inches. If we did a horizontal here, did our center lines, cut from corner through center, we would add 9 inches to the 6 foot, get our 6'9". Alternately, we could also just take this box, which we know is now 18 inches as well, and just start cutting it in halves and get us to right where we want to be. And there's no question in this case of the accuracy. From there, just transferring things back. You want your figure in the background, and so now let me make this a little bit thicker so we see it well. Your 6-foot figure is at this height in the room. Obviously, when we do furniture and things, we want to start working that out. That's where the divisions can come in. Where is the knee in respect to the middle of the torso? Where does the head end in regard to the upper quarter? We can break all that down. We are not concerned about that in perspective. Figure studies will do more with that. Figure drawing will do more with that, with understanding those proportional relationships. But we should have some general relationship between something like a table, a couch, things that are on a human scale. So again, thinking about this idea of measurements, so if we want to start cutting things in half, you're looking at a toddler, 3 years old roughly, you can go 3 foot high, you're in the ballpark. You can get those things down to where it makes sense. You want someone sitting, how far, if they're sitting up straight from the tailbone up to the top of the head, you can work that out and you can make sense of it. And it doesn't have to be arbitrary, and it still can show that sense of understanding. Working back, just to kind of recap figure scaling. So if this is our first figure, this is our second figure, we can go ahead and do our third. Let me get rid of the arrows for you. And this process should be pretty easy to understand, but if there's something about it that just feels off or is not clear, let me know. But based on the other things we've done to this point, this is probably one of the simpler things we do during a week. Now we're looking at not just necessarily a room, but a larger field. This 6-foot person here. So if you put a car in it, you don't want the car to be twice as tall. You want it to be near the human scale that we're working with figures. Hopefully that clears up some of these differences in height. I know that this isn't going to answer all the questions, but this is to get that process started and making sure that there's a clear understanding that the expectation is you show how it's done in perspective, using the processes we've learned, or using an external credible source. I have no problem with that. I've suggested books, other perspective books. I have one in particular that I typically suggest a lot, that does an exceptional job of taking what we've learned and kind of doing those next steps. And I have no problem with that, but I need to understand that you know what's going on, and that's a core of any time we have an assignment, especially in the final, showing that you can justify the conclusions, that it's not just kind of an arbitrary decision.